Forum will be done, so that's a good thing. I'm struggling this morning. So we're going to follow the steps on your sheet to solve these radical equations, but there's a couple things I need to talk about first as far as how to solve here. All right, so step one, and when we're talking about radical equations, we're just talking about equations with radicals in them. So for example, just looking at number one, the square root of x plus 5 equals 12. So some equation that has a radical somewhere in there. Remember, we've talked about different types of radicals. We've talked about different roots. What's the root for this one? 2, because if there's not one there, it's an implied 2, right? It's a square root. All right, so my first step in solving these is going to be to isolate the radical. What does isolate mean? That's exactly right. Get it by itself. So isolate the radical. So when you look at this one, how do I get the radical piece by itself? Subtract 5. That's exactly right. So I'm going to move that 5. And now I have the square root of x equals 7. Is everybody in agreement here? All right, so I've got the radical piece isolated, which was what I wanted. And so now what I'm going to do, if you look, it says raise each side to the equation of the power of the index to eliminate. That's really, really wordy, okay? But let's think about the step is really to eliminate the radical. So let's talk about how we can eliminate the radical. Somebody said 2, and you're exactly right. If you raise both sides to the second power, that's going to get rid of that radical. Do you agree? But what if that was the third root of x equals 7? How would you then get rid of the radical? The cubed. That's exactly right. And if it was the fourth root, you would do a 4. That's exactly right. So that's what that step means. Whatever that root is, I'm raising that to both sides to eliminate the radical, because that's how you get rid of it. So now I have x equals 49. Okay. Now you may find yourself in a situation where your equation is not completely solved at this point, and you may have to go through and continue solving. But for us here, I've already solved for x, so I'm good and I can stop. Does that make sense? Now there's an extra step on there. What does it say? Step 4. Extraneous. Check for extraneous solution. What is an extraneous solution? Nobody? Do you know? So an extraneous solution means when you plug it back in, it doesn't work. And you need to be really familiar with these. So if I plug 49 in for x in this equation, does it work? So is the square root of 49 plus 5 equal to 12? Yes. So 49 is not extraneous. 49 is the actual solution. But this is how I check to see if it's extraneous. You all with me? Pretty easy? All right, let's do another one. Let's do number 2. We'll work through as many of these as we can get through, and you'll finish them for homework, and then we've got another page there. All right, number 2, same steps every single time. Isolate the radical, get rid of the radical, and solve. So how do I get the radical by itself here? Why are you moving the radical, not the 3? That's exactly right. No, it's not wrong if you move the 3 first, but it is easier if you just add that fourth root of m to both sides. Now what? Put the 4 on the 3, raise both sides to the 4th power, because it's going to eliminate here, right? And what is 3 to the 4th? What is it? 81. That's right. I'm sorry, I didn't hear you. And now I just check to make sure that it works. If I go back and plug it in, is 3 minus the fourth root of 81 equal to 0? Well, what's the fourth root of 81? 3. So yes, it works. I know it looks like they're always going to work, but they don't always work. Let's look at 3, because 3 looks a little bit different, right? What's different about 3? There's like a whole equation or multiple terms there under the radical. Same steps though. I'm going to get the radical by itself first. So what do? You subtract the 10. That's exactly right. So when I move the 10, I end up with the square root of a plus 7 equals 1. Now what? Raise both to the second power. That's exactly right. This is gone. So I have a plus 7 equals 1. And now what? You just subtract the 7. So a is negative 6. Check it. Make sure it works. If you plug 6 in for a, does it work? Does it satisfy the equation? Yes, so it's not an extraneous solution. Look at number 6. Now I'm skipping around a little bit here. I told you these were radical equations, and I don't see a radical here. So somebody could change it to a radical. That's exactly right. Because this is to the 1/3. That's the same thing as what? The cubed root. That's exactly right. This is the same thing as this. Can you solve it now? Sure. What do you do first? Subtract 11. That's right. Move the 11. Isolate that radical. Not today. The third root of 7p minus 1. 7 minus 11 is 8. What do you think we do now? Now you just told me you're going to do better. What do I do now? You put the cube. That's exactly right. So if I raise both sides to the third power, I have 7p minus 1. That's exactly right. Now what? Subtract 1, add 1. That's right. So 7p equals negative 63. That's exactly right. These aren't hard, right? So if I'm plugging in, yes, so it would be, I get back to this original, so does 7 times negative 9 minus 1 to the 1/3 plus 11 equals 7. You put it in your calculator like that to see if it works. You didn't get what? Okay, when you're raising it to the 1/3, did you do that? Everybody good? You said 5? Okay. Number 5. Negative 36 equals 9 times c minus 12. Again, I don't see a radical on here, so tell me what that means. That's right. Well, you can't distribute first, and the reason you can't is because exponents come before multiplication in order of operations. So I can't distribute. Switch it around how? You could if you wanted to. You could. How do I isolate the radical? Divide by 9. That's exactly right. Is it? Sorry. Well, that's going to be nice because whenever I divide here, I'll get a positive number. Now what? That's right. Eliminate the radical. Get rid of it. Raise it to whatever power you need to get rid of it. Now I have 16 equals c minus 12. And this is an easy solve from here, right? Add the 12. So I get 28. Let's see. Now, when you flip over, yeah, we get into some kind of different situations here. Yeah. That's okay. We get into some situations where there's two radicals, okay? So when there's two radicals, it's a little bit different on how we're going to solve. So what we want to do with two radicals, and if you want to make yourself a note somewhere, I don't know why this is not on here, I apologize. Two radicals. We want to separate the radicals on either side of the equal sign and then eliminate the radicals. Now, this sometimes leads to a lot of work depending on what else is there because there could be other stuff in there too, and I'll show you what happens when we get there. But we'll start easy with number 9 and then we'll do something a little bit harder. So number 9 says that the square root of u minus 8 is equal to the square root of 43 minus 2u. So they're already separated on opposite sides of the equal sign. So how do I eliminate them? What? That's exactly right. Raise them to the second power. Put a 2. So several of you all said the same thing. If I do this, I end up with u minus 8 equals 43 minus 2u. And now this is a solvable equation for me, right? What should I do first? Add the 8. So I get u equals 51 minus 2u. What now? That's exactly what I would do too. I would add the 2u so that I get those u's together. Now what? So if I divide by 3, goes in 17 times. 17. You're ready to kick it up a notch? So we've got two different situations. One radical, we isolate. Two radicals, we separate. Okay? But what happens? You got that? What happens if I'm in a situation like number 15? I have one radical, but I've got some other stuff over here. It's not just a number, stuff. The radical's isolated. I've done that. What can I do now? You put the 2. You're exactly right, because that's what I do. I eliminate this. But when I come to this side to put the 2, can I distribute that exponent in that parentheses? Nobody wants to say because they're not sure. Can I distribute the exponent through to the parentheses? Okay, so let me ask you this. Does this equal this? No, why? It does not, because this equals this. Yes? And if it equals that written 2 times, that means I have to do what to find out what it is? FOIL it out. That's exactly right. So this is actually m squared minus 5m minus 5m plus 25. Oh. Which is definitely not the same thing, right? I'm missing that middle term there. So back to my equation, I now have 6m minus 38 equals m squared minus 10m plus 25. And I'm in a whole new situation now. Now I'm in the situation where I have a quadratic that I have to solve. So I'm back to unit 1, right? How do I solve a quadratic? What do I do? What are my steps here? Okay, so I would, but first something has happened before I do all that. What about my equation? What do I have to do to that equation before I start solving? Get everything on the same side. That's exactly right. I need my equation to equal 0 before I start. And remember, once it equals 0, I can factor and solve. I can complete the square. I can take square roots. There's a lot of different ways that I can solve a quadratic depending on which way. But hopefully we can factor and solve it. That's the easiest. So if I want everything to equal 0 and I want my leading coefficient to stay positive, what needs to move? The 6m minus 38. So I need to move this and move this. Now I have a quadratic that equals 0. I need to solve it. So how am I going to solve? The other way you can. Yeah, it doesn't matter. If you like to look at it this way, you certainly can. Can I factor it? How do you know? -7 and -9. That's exactly right. What multiplies to positive 63? And I can shortcut this, right? Because there's a leading coefficient of 1. So what multiplies to 63 but adds to -16? -9 and -7. Which means my solutions are what? +9 and +7. That's exactly right. Y'all just thought factoring was going to go away, didn't you? Quadratics. They never go away. All the way through calculus. So yes. So here's why extraneous get important here. Because one of these will work when you plug in and one of them will not. So if you go back to the beginning, and you can use your calculator to do this. If I did the square root of 6 times 9 minus 38 equals 9 minus 5. That's one that I'm checking for extraneous, and then the other would be the 7. One of them's not going to work, and I don't know which one it is. 7 does not work. You're seeing if it equals itself. I'm going back to the original equation, and the first thing I plugged in was 9 to see if that worked. Do they both work? They might both work. Sometimes they both work. Yeah, they would both work there, yeah. So these are both actual solutions. But if you get to the point where it doesn't, you would say, okay, well, mark it. You would just say this one is extraneous, but you'd still need to show it. that make sense? Let's do at least one more. I want to look at number 18 with you, and then I'll be done. 18's a little bit harder just because of what it is that's... Remember, if you can't factor, what's your option that always works? The quadratic formula. That's exactly right. What do? They're separated. So I need to square it, right? I'm in the situation of two radicals, so I just need to make sure that both radicals are on opposite sides of the equal sign. Past that, I'm ready to just eliminate radicals. So here, if I square both sides, I'm still in a position to have to FOIL this out on the right side. You have to square the whole side. So just like before, where I wrote it out twice, I'm going to do the same thing. All right, so let's see what happens. I have x plus 9 equals, what's the square root of x times the square root of x? X. Then I have minus the square root of x minus the square root of x plus 1. Gross, right? This is the hardest that we're going to get in here for these. I combined the like radicals in the middle. They were the same radicand, the same index, so I could combine them there. But now I'm in a situation, I don't have a quadratic, right? So this is not like a just make it equal 0, factor, and solve. What in the world do I do? Bless you. If I square it like it is now, I'm not real sure what's going to happen. When you're in a situation with a radical in your equation, what did I tell you to do?
Cannon High School, please stand and
Get it by itself. So I'm back to a one radical situation on the announcements. But when you get yourself back to the situation where there's only one radical, get that one radical by itself. And so that's exactly what I did. I moved everything that wasn't hooked to the radical. So I subtracted x and subtracted 1. Conveniently enough, the x's canceled. Subtracted 1. So I had 8 equals negative 2 times the square root of x. So the radical is still not by itself. So whenever I divided by negative 2 on both sides, the radical did end up by itself. And I was able to just raise both sides to the second power to eliminate it.